Hello everyone and welcome to our Inazuma 11 dataset presentation. Today we are Jungle DIFF. These are the 5 members of the group. And we are going to talk about this dataset. What I asked to myself was if a goalkeeper can also be another player in the camp. So like a defender, a midfielder or something. The first I did was cleaning the data by removing some data like the player's name, the player's team, element, two stats called FP and TP, which we are not going to use, and all the techniques names. So what I did was 3 steps. First, I checked which of them were a goalkeeper, when they were I1, and I0 was another player that was not a goalkeeper. Then what I did is a little formula to see if the goalkeeper was more defensive or more offensive, to see if they are more likely to be a striker or a defender. And the last thing I did was the stat balance. What it did was to compare the max stat they had to the minimum. So what we had at the final graphs is to 21% of these players were goalkeeper. The stat balance is like the max stat is like 70 more than his less, which is a big difference. And we can see in this graph right here, down in the right, that 38% of the goalkeepers are more likely to be a striker more than a defender. So thanks to Jesus, my teammate that is going to explain it later, we can be completely agreed that a goalkeeper can also be in another position.
Hello, my name is Pablo, and the goal I want to achieve was to get the best 11 team for each element of the game. As you can see here, each player has its own element. There are 4 elements, which are earth, wood, wind, and fire. The first thing I did was to clean the data to remove the information that I didn't need. For example, the team of each player, as you can see here. I don't need that data, and I neither need the move that a player can learn. The next thing I did was to create new sheets with all the data, and I select only the the element of the players that I want to be in the team, as I have to do for different teams, once for each element. Then I sort the players by their positions, so it will be easy for me to do the average for all of them. As you can see here, I did the average for all the players, all the wood players, the wind players, the fire players, and the earth players, uh, by doing a new column in which we can see the average for each one. Then I did a new another sheet in which I select only the best players for each positions. For example, the goalkeeper, we only need one. The 4 best defenders, the 3 midfielders, and the 3 forwards. I did this for all the 4 elements. Then, with that information, I create the teams. As you can see here, we have the fire team, the wood team, the wind team, and the earth team. Now here we can see all the graph that I did. For example, I did the same for each sheet, as you can see, for each element. We can see here the wood goalkeepers with the name and the average of each one. For example, here Felt is the best wood goalkeeper. And last, I did another graph in which I compare each team. For example, we can see here that the best average of the 4 teams that I did are the wood team. And that's all. And my teammate is going to talk about his goal.
Now I'm going to talk about my question, which was to see the distribution of all the stats of the players, taking into account their positions. And for that, I cleaned the data for that, I just removed all the non-numerical values, just such as their the player names, their teams, and their moves. And now I just have all their stats in numerical values and all their position. After that, what I did was to make the average of all their stats info in with their positions, separating it with their positions. And after that, I just took the best stats of all of them and to make the normal distribution. As we can see, just as a detail, the defense's positions have their best stat are, of course, defense stats. For the same for the midfielders and the forwards with offensive stats. After that, I made a graph to see compare all their stats, and we can see a detail that it's quite anti-intuitive, that they basically have the same average in all the stats. And offensive players should have better offensive stats, and that's not like that, or the other way around with defensive stats. After that, I took all the values of all the players of each position, and I made the normal distribution, as we can see here. And after that, I compared the probability of those stats of being out of the average with the theoretical probability of being out of the average. And we can see that they are pretty similar probabilities, so we can assume or just think that they didn't make or distribute all the stats with high mutations. Now I will let my teammate to speak about his work.
First of all, what I did was to clean the data, so I could take out all the information that is not needed for the process of the question. And what I did was to eliminate all the useless rows and set a minimum, the quartiles, the median, the median, and the mean of all players, divided by the stats and by the element. I did this with every element and every stat. Next, we can see the graphics with all the box plots first by individual stats. Here we can see that at first glance there is not any difference between any of the stats and between their element. We can see that there's slight variance, but at first there's nothing that rings the bell. For example, we can see that fire in word in here, it's a little higher in between the third quartile and the fourth quartile, to be more specific, but the median is almost the same on all of them. What we can say is that in almost all of them, the minimums of Earth are very low, almost in every of them. So it's the worst element in terms of the minimum statistics of all of them. Next, we have the box plots that shows the distribution of all the stats by every element. Here we can say that clearly there's not any significant difference between all of them. What we can say is that the wine and the wood elements are more equal between them than the fire and the earth, for example, that have higher changes. Here we have two stats that are very different for the rest of the group, but they are not that important.
Hello, I'm Nicolas, and now I'm going to talk about my analysis that was finding the most frequent movements and combinations among the Inazuma 11 players. I also wanted to understand how movement combinations are distributed and visualize in a chart how they are done in the game. Okay. Now with the procedure, I created all possible pairs in a table of every player For example, cold hand, grenade shot, as we see in the first one. Now, in the second point, I made sure not to count a pair twice if it was reversed with a very easy formula. I created a new table for that, as we see in the second table. And finally, in the third point, I use a pivot table to count how many players had each combination and sorted the results by highest to lowest frequency. Finally, in the results, we can see the final table. And by looking at the data, I noticed that the most common synergy was attack scan with defense scan with 22 players having that synergy, because that special movement needs to be together. The second one is Earthquake with Sumo Stomp, which has 12 players, and we can see that the numbers drop quickly after the top pairs. For example, there are 32 combinations that appear 5 times and 62 that appears 4 times. And in the final chart, we can see that more than half of all combinations appear only once, which shows that the players are very diverse, considering there are about 500 players in total.
That's all. Thank you for your attention and have a good day. Bye bye.